Well, thank you, sir. And hello, everyone. Thanks for joining us. Um, I was asked if I wanted to talk to this group, and I figured, well, let me tell you what I've been doing for a little while now. Um, so I am the founder of Gallium Data, which I'm going to be talking mostly about today and how it came about. Before that, I was a co-founder of Espresso Logic, a company that was then acquired by CA, which was then acquired by Broadcom. Has anyone acquired Broadcom yet? That's just a matter of
We're
time, I guess.
actually we thought about it, but we have no money.
Yeah, yeah, you're going to need a fair amount of it.
We tried to trade Rich. They said that wasn't fair.
I can't really blame them. All right, so what is this? Ooh, admit. All right. So we're going to be talking a little bit about databases, and in particular, how you communicate with databases. So, like probably most of you have been working with databases all my entire life, and they're great and they're fun, and there's lots of them, but they can't do it all. And what I noticed over my career is that changing databases, and for that matter, changing database clients, such as applications and middle tiers, can be tricky, difficult, expensive. And I've come to realize that sometimes you just need to tweak things in the middle. In other words, you need to change the way uh, client and servers are talking to each other, and that's basically the general idea behind Gallium data. So let me give you sort of the standard presentation on Gallium data, and we'll see how that goes. Okay, and then
Max, we just lost the screen share.
Yep, sorry, I need to share that now.
Okay.
There you go. All right, we should be back online. Okay, so what is Gallium data? So Gallium data is what I call a programmable database proxy, but what does that mean? So when you think about a database usage, you think about a database client, and by that I mean, you know, a web app, an app server, a batch job, a report, anything that talks to a database, literally. And then you think about a database server of some sort, SQL, NoSQL, whatever. And then there's a network between the two, and the two exchange messages. So the database client is going to send a request of some sort. Here it's SQL, but it doesn't have to be SQL in the case of NoSQL databases, obviously.
Hey,
And
Max.
then the
Is your slide supposed to be moving?
Yeah, your slides aren't advancing. We see what is Gallium data.
oh my, I'm sorry. Your screen sharing is paused. Oh, okay. I don't know. Come on.
We are live,
Resume.
folks. It's okay.
Resume share. It's not resuming. Okay, let's stop the share then. Let's start sharing the screen again.
By a count of votes, and whose fault is this? If you think it's Rich's fault, please raise your hand.
No, this isn't PowerPoint, man. If it was PowerPoint, it'd be me, but
Okay, now it says you are screen sharing.
yes,
Am I screen sharing?
Yes.
Okay.
You are. I see database client, database server with a select star from customers and a blue box now that says Gallium data.
Very good. There's hope. All right, so that's what Gallium. That's the place of Gallium data in the world, between database clients and database servers. So neither the client nor the server knows about this. The client sends the requests to the proxy, and at that point, the Gallium data, the proxy, may decide to modify that request and then sends it over to the database server. Then the server comes up with a data, whatever was requested, sends it to the proxy, at which point the proxy might decide to, again, change that data, maybe remove some records or whatever, and then it sends it back to the client. Now, why would you want to do that? So let's take some examples. Let's assume that we have an urgent new business requirement, which is that anyone in Canada retrieving information about accounts over $10,000 must be recorded for whatever reason. And then, of course, existing apps need to be changed, or maybe something in the database needs to be changed, but usually that's a major hassle. So with programmable database proxy, we can do that in the middle, so that when the record comes out of the database, it can be intercepted by Gallium data, examined. The Gallium data is going to decide, oh, this is Canada, this is over $10,000. We need to record this. And then we're going to send that to the database client. The beauty of it here is that neither the database client nor the database server had to be changed in any way, shape, or form. They don't know that anything has changed. Only the proxy knows that. Let's take another example. Let's say we have a new business requirement that orders over $1,000 can no longer be deleted. So again, here, the proxy can intercept requests this time and actually modify the request so that by the time it gets to the server, it satisfies the requirement. Again, the client has no idea that this is going on. Final example, these are, a little Mickey Mouse, but not completely unrealistic either. As you may know, the Czech Republic has changed its name. It's now called Czechia. And we need to change our database to reflect that, but we've discovered that some legacy apps are unable to accommodate that change. They just have some logic that's hard-coded to that. That's a poor decision. It shouldn't have been, but that's just the way it is. So here we're looking at using the database proxy in the other way, which is when the data comes back from the server through the proxy is going to look at the data and potentially change that data for certain clients. So here the proxy is going to be programmed to actually decide, given the fact that this is this type of data, and given the fact that I am now talking to this type of client, I am not going to change the data according to some rule, which in this case is expressed as a simple bit of JavaScript logic. All right, so that's what Gallium data does. It can observe all database interactions. It can control the requests and the responses, and it can transform them as needed. So how does it work? Well, it's a proxy, so it works at the wire protocol level. It inserts itself in the dialogue between database client and database servers. And the most attractive part of all of this is that it does this completely transparently. Literally nothing has to change in the client and the server. All that has to be done is typically changing some sort of network setting or something like that, so that the database client now talks to the proxy instead of directly to the database. And we're gonna, I'll show you sort of how this works, but that's sort of the gist of it. Right now, this runs for Postgres, Mongo, MySQL, and SQL Server, with more databases coming up. Redis, we have a user right now that's asking us for SAP HANA. So that's just the list is gonna just continue growing. Each database can take, anywhere between a little bit of work and a fair amount of work, depending on the protocol. So what are the supported clients? Well, since we work at the wire protocol level, by definition, all clients. It really doesn't matter what language or drivers or whatever, because we work at the wire protocol level, all clients are supported without any changes, any language, any platform, and so on. Also, as a side benefit, because we work at the wire protocol level, it turns out that some databases actually use other databases protocol. So the MySQL protocol, for instance, is used by other databases. The Redis protocol is also used by other products. How much does it cost? Well, at this point, it costs literally nothing. We don't want money to be an obstacle to adoption, so it costs nothing. All you need is Docker or something that can run Docker containers, like Kubernetes or Containerd or whatever. You can run it on-premise in the cloud. You can run as many copies of it as you want. That's up to you. All right, so that's the spiel.
Real quick.
Yes, sir.
What about encrypted connections?
Oh, of course. If we didn't support that, we wouldn't have a product. So yes, absolutely.
Okay.
So the notion here is that you are a man in the middle, literally, or I'm sorry, a person in the middle. But you are an authorized person in the middle. So you're going to have access to all the certificates, all the private keys that the database is using, and therefore you can install them on the proxy. And that's why the client, like I said, is going to be completely fooled. It's going to connect to this thing. All the certificates are going to check out. It's like, I'm talking to the database. Well, you're not, but it certainly feels like you are. All right, so let me go back to, my presentation here.
I was gonna say it's that we have a various group of developer backgrounds. Maybe in the future of your presentation, you probably answer this: is what is a wire protocol? I remember it because I took B. I can balance a B plus tree on a oak tree, but not everyone can.
Excellent. Well, you may be sorry that you asked this question because I'm gonna talk about it in eye-watering detail.
Is there a test?
So what is this all about? So the reason why this came up is that many of you may remember, how did Google get started? Remember how basically Google made a realization that the other search engines did not, which is that it's about the links. It's not about the sites. That's really where a lot of the value is. And with database connections, that's kind of the same, realization that came to me. The fact that when you have a database client and talking to a database server, there is kind of an invisible third person in the room, and that's the connection itself, which, because a database connection by definition uses an interface where we have formalized requests and formalized responses in the form of, let's say, SQL queries and result sets for SQL databases. But again, this is not restricted to SQL databases. This works equally well for other types of databases. So the idea of inserting your logic into this connection seemed to have some really interesting potential. So let me just sort of show you the product real quick, and we'll see where we go from here.
I feel like you're gonna get super nerdy here in a second.
Well, yeah, probably.
Over under and that we see hex.
Let's see.
If I see Face Cafe, I'm going home.
All right, so sharing, and I'm gonna try to share.
No, yeah, Scott has a question about the big O notation and the impact of the encrypted lines. I'm getting sarcastic.
I was going for it.
He just slacked it to me. Is this non-polynomial? Is this MP complete? And could you justify why?
Well, a question that does come up is the question of performance, and of obviously going through a proxy, there's very slight performance impact, but it's usually so small as to be completely negligible. If in terms of performance you are running absolutely at the ragged edge and you cannot afford another 2 or 3%, then this may not be an option for you, obviously. But I have yet to run into a situation like this. All right, so let's try to share this here. Okay, this will work. So let me sort of give you an example here. This is the product itself, by the way. This is Gallium data. Not a sexy interface, but then again, we're not really trying to be sexy. We're just trying to be useful. So what have we got here? I have 3 Docker containers running. One that's running Microsoft SQL Server on Linux, by the way. It works actually surprisingly well. in this instance of SQL Server, I have some little Mickey Mouse database here, and I have a list of products. So if I were to query my data, I can just sort of go around and see what's going on. Now, let's assume that I'm looking at this and I'm deciding, well, we have some products here. I'm sorry, some products. And some of those products are discontinued and I don't really want to see them. So in my client, we're going to use this as a client application. I really don't want to see these discontinued products. So I could obviously change my application or maybe create a view in SQL Server or whatever. But if these are not attractive options, if instead I want to say, well, I just need to change the way the application works, but I can't really change the application or the database easily, that's where using a proxy comes in. So here we're talking to the database through Gallium data. Therefore, I can go to Gallium data and I can say, well, let's filter out these discontinued products. I'm going to look specifically for some type of requests and then execute a very small amount of code here to modify that request. So I'm going to activate this query here. And now if I refresh this, suddenly my discontinued products are gone. That's because the request has been intercepted by Gallium data, modified, and then sent to the server. So the application doesn't know it, but it is now executing a different SQL and therefore getting different results.
Max, so like, there's a question, keep in mind, some people maybe just started their software development. And some people are like Rich and probably should stop software development. He's been in it so long. What problem would this solve? I mean, this is the leading question. I know how to answer this, but where would you see this? Where, hey, I can't change the code, I can't change the database, but
I have a real live example from yesterday. We can't find the source code. It's archived in TFS somewhere, and we're not quite sure how to get it out of there. But we need to make a change for the business by May 1st.
Exactly. The other classic example is I don't own the application. It's a third-party application. It's doing everything I need except this one damn thing. And if only we could just tweak that little thing, my life would be perfect. But I can't. I literally can't change the application. I don't own it. I don't have the source code.
And before you made this product, right? And because we're trying to create a space where people can learn. What would you do before this thing existed? What would you do other than cry?
Well, there was really not a whole lot. So the concept of a database proxy obviously is not new. There are quite a few out there, but not very few, or I should say very few of them are really programmable. Database proxies right now are used mostly for things like scalability, security, things like that. But in terms of actually changing the behavior of the system, either by changing the requests or changing the responses in a very flexible, very dynamic manner like this, I've only found one or two other products, and they're really, one of them is actually discontinued. It was MySQL proxy. And the other one tends to really focus purely on security.
Great. I mean, so it's really interesting. And I'm just going to add this to people that are, there's a learning demographic out here, this is common in a lot of manufacturing, a lot of banking. Scott, I mean, I know your background. Scott, you've seen this too, where you got to make a change, but you can't change the code.
Yeah, definitely. A lot of the source systems for like insurance are really older systems that maybe the source code is there, but don't have people that know how to make changes to it anymore.
And just illustrating as you go on your coding journey, this is not an uncommon problem, and like this will be something in 10 years you may encounter and think, oh, wire protocols.
So let me give you another example, sort of going the other way. So far, we've seen changing requests. So if I were to look at my customers and decide, I'm not really comfortable exposing the first name of my customers. So I'm going to go into Gallium data and activate a different filter. And this one is literally just a one-liner. And when I activate that, now I'm only exposing the initial of my customers. So this is a very simple example of masking. So many databases have a way of masking data, but it's usually fairly blunt. With Gallium data, you can be extremely specific. I want to mask only certain data in certain ways, in different ways, depending on the row, depending on the time of day, depending on whether you're accessing the database from North Korea or not, et cetera, et cetera. So that's really all, the main value here. That's very, very, very flexible, and can, do pretty much anything you need to do. All right, so let me stop sharing this here and move back to this. Do and share. Okay. So since we're among nerds here, I figured I'd probably want to tell you a little bit about how this is done. The entire thing is just one. It's one Docker. It's all developed in Java, and it's using the Java Graal VM, which I'm quite fond of. So it's one of the many Java virtual machines out there. Its main advantage is that it has a built-in JavaScript engine. And unlike other past JavaScript engine written in Java, this one is really serious. It's Node compatible. It's JavaScript 2020 something compatible. It's really up to speed, and it works very well. It also has excellent debugging APIs. I didn't show you that, but Gallium Data has a full-blown debugger, which means that you can step through your code one line at a time, see the values of variables and so on, which is really helpful when you're dealing with stuff on the wire. Why Java? Well, it's very mature, and I've been using Java for 25 years. It's got excellent performance. I actually looked at other languages when starting this, things like Go and Rust, but I just went with Java in the end. It's supported by everything, and it's it's been around long enough that I'm confident it's still going to be around by the time I retire. On the front end, we're using Vue.js. I actually looked at React and Angular. I used Angular quite a bit when it first came out. These frameworks have just become monsters. I know they do a lot, but good God, have you downloaded something like Angular, the newer Angular, version 58 or whatever it is now? It's just staggering, the thousands of packages, and
it's
anyway,
why
that's the
it's why ATT upgraded fiber at my home to 5 gigs.
Yeah. So Vue.js is still fairly simple and elegant, and it was just sort of an immediate connect. Try it, and it's that's exactly what I was expecting. So I like it, but React is probably the most popular one. So and then we're using the material toolkit, which is probably a mistake. I kind of wish that we'd use something different now. Maybe something like Bootstrap or whatever, but material is okay, but it's just not the best toolkit, front-end toolkit that I've seen. So when talking to databases, clients, and servers, we're talking obviously about protocols, network protocols, and so for the past amount of time, I've been dealing with protocols at an extremely detailed level, and I'll show you how it's done very quickly. But one of the major challenges is really the protocol documentation. Can we figure out how the bits are organized on the wire as they go back and forth? And the documentation goes for anywhere from very detailed, like Microsoft has done a fantastic job of documenting their database protocol. It's vast, it's really big, but it is documented, and therefore It's doable. Oracle, on the other hand, has absolutely no interest, none, in telling you anything about this wire protocol. So the only information that's available out there has been very, very painfully reverse engineered by nerds like you and me. And there are still massive amounts of complete mysteries. Nobody outside of Oracle knows exactly how it works. So how do you figure out these protocols? Well, by using Wireshark or something equivalent, but I use Wireshark myself. Wireshark is might be a little intimidating at first, but it's actually your friend. So Wireshark is a network protocol debugger, which means basically it allows you to crack open a network connection and literally see the bits flowing, back and forth in terms of packets or whatever. Wireshark is available on all platforms, and it's really nice. In fact, so nice that I'll just show you what it looks like real quick, because there is no reason to be afraid of it. So this is Wireshark here. So what we're looking at in the top portion of the screen here is the packets, in this case, TCP packets, being sent between these two ports. So this is the origin port, source port, and destination port. And then I can look at a particular packet and see its contents. So you can see, we all remember our sort of networking 101, right? The layers of networking. So here it is. This is Ethernet, this is IP, this is TCP on top of IP, and then this is, in this case, Redis, I think. It's encrypted, so it's not necessarily readable. So if you've never used Wireshark, I would encourage you to just take 5-10 minutes, install it, try it out, and just get a feel for it. It's a fantastic debugging tool. It's a pretty heavy hammer, but sometimes there are things that can be done in no other way. So that's the end of my pitch for Wireshark. I don't get paid for this, by the way.
Did you sell Wireshark to Broadcom?
No.
We may want to sell Canton Coders to Broadcom if you get a chance.
Wireshark is free. Now, Rich asked about encryption, and encryption has been a part of my life now for some time. So yes, we do have to encode and decode data. So when you're talking to your SQL Server, very often you're going to be talking to your SQL Server over SSL, or more likely TLS, but same difference. That can be a bit of a bear, I have to admit. Getting it right, and in particular, some databases can switch their protocol dynamically. In other words, you connect to the database, and then the client and the server agree, oh, you know what, we should switch to SSL. And that means that we have to do the same thing. Obviously, Gallium Data has to support this kind of dialogue, and that can be tricky, but it can absolutely be done, and it has been done. All databases that we support, MySQL, Postgres, SQL Server, obviously support SSL, and therefore we support it there. The debugger, the debugger. So the debugger is using the debugging APIs in the GraalVM Java virtual machine, and man, it's been a trip. I don't know if anyone here has ever written a debugger, but it can be challenging. Thankfully, GraalVM does a really good job. It's just an inherently complex problem. How do you control and manipulate a program literally while it's running? Setting breakpoints, retrieving the values of variables and things like that. But the debugger is in fact fully working. It is language independent. Another thing that I forgot to mention is that GraalVM supports languages other than JavaScript. It also supports Ruby, Python, R, and others. So that at least opens the possibility that we could have scripting using some of the other languages, in the logic. I'd be interested to hear what you guys think. So we do have some telemetry in Gallium Data. but it's completely anonymized. So what that means is that when someone starts an instance of Gallium data, after a while, we're going to get a ping, but all we're going to know is somebody in Ohio is running Gallium data. That's it. And that's because we wanted to get a feel basically for adoption. But I'd be interested to know if anyone thinks that's sneaky or intrusive or anything like that. There's no PII, no user data, nothing like that. Just basically the knowledge that somebody is running the software, but we don't even know exactly where, and we certainly don't know who it is. So anyone can try it out. All you need is Docker. If you have Docker running on some platform, you can try it out for yourself. There are step-by-step tutorials that show you how to connect to the database and how to modify the traffic. And we keep seeing new and interesting applications of this. And that's about all I've got right now. So any questions?
So why don't we do
or
this?
Comments?
So just looking at my OBS, making sure everything's working, just to make sure that people feel comfortable asking questions. Is it okay if we quit streaming right now? And then we'll just leave the Zoom session up. So if you're somehow watching live on the internet, jump on our Zoom. And if you can't get here, sorry. But I'm going to turn off the stream right now just so people can turn on their cameras and mic and not feel like they're being rebroadcast to the internet, because they're not. All right.
So I got a couple of hopefully quick questions. So the scripting language for the rules is basically JavaScript, but that's being run using something else like Rhino or whatever inside of a Java process. So this can handle massive concurrent, well, up to the limit of your VM, this can handle massive concurrency, right?
Absolutely. So we've tested with thousands of concurrent connections on a single server, and you can scale the server out. So if you set it in let's say a Kubernetes environment, you can very easily have a TCP load balancer in front of that that will then distribute the connections, and therefore you could have n number of instances, and therefore scale it out even further. So yeah, we literally have not found any scalability limits yet. I mean, nothing's infinite. There's got to be some limits, but we just haven't found them yet.
Sure. Cool. Yeah, because like what I'm thinking about is the JavaScript single-threaded problem of, hey, I did a cool thing, but I'm in JavaScript, so now I'm backlogging socket connections like a son of a gun, and that's no good, right? So,
correct. So every connection gets its, conceptually its own JavaScript engine, and you're right that conceptually JavaScript is single-threaded, but it is running in a Java environment, and therefore that's not really an issue.
Out of curiosity, what framework did you use to run a JavaScript interpreter? Is that like Rhino, or what is it?
No, so this is built into GraalVM. GraalVM is an effort by, I think, Oracle to come up with sort of a next generation JVM. And what they have is kind of a generalized virtual machine that can run Java and JavaScript and Ruby and Python and R and. But so it's still a JVM, and therefore its native language is still Java, but it can run other types of executables. Basically, it compiles the JavaScript down to Java bytecode.
Gotcha.
And then you run at the full speed of the bytecode. I mean, it's still JavaScript, but it does a fantastic job. And frankly, I am amazed. That was one of the first things that we looked at the beginning, which is, well, it sounds like this is going to work, but I mean, what about performance? Surely JavaScript is going to be a problem. Turns out, wow, these guys did a fantastic job, and the code runs much faster than expected.
Is GraalVM free, or is it?
Yes, it is.
Okay.
There is a professional edition. I'm not sure what the difference is. I think it's mostly support. But you never see GraalVM when you use Gallium data. Gallium data comes as a Docker image, so you run the image and you never have to see it.
Cool.
Any other questions from the audience? This is really nerdy, by the way, Max.
Oh, well, thank you.
Like
I tried.
I saw hex on your screen on Wireshark.
What are you going to do things like so an interesting thought as you were describing some of the things, and I was thinking back on the history of places where I didn't have the source code. Are you going to support things like DB2 and DB400?
Possibly. This is really basically depending on the demand. SQL Server was the first big database that we had serious demand for. Like I said, we have a partner right now that's asking us about SAP HANA. It turns out SAP HANA is very open, very well documented, so that's shouldn't be a problem. Don't know about DB2. I haven't looked at their protocols yet, honestly. But if their protocols are well documented, then sure, it's just a matter of.
It's IBM. I'm sure there's a manual somewhere.
It's probably on paper.
Surely.
Yeah, no, I mean, like the last instance I recall of we can't change that was some brick of COBOL code trying to talk to like a DB2 database running on the mainframe, and we were playing silly games like, well, what if we added some triggers to the database because we can get in there, but we can't change the COBOL code because nobody knows where the source is.
Right. Yeah. Yeah. There are so many examples of that. It's kind of funny because when I do this presentation, very often people sort of jump in and go, kind of like you, Rich. Oh, I literally had this problem yesterday. So the last time I did this presentation, the guy I was doing the presentation to just told me, we literally have this problem right now. We have this application that's running this SQL query that's just killing the database. It's terribly expensive, and we know how to fix it. It's just that it's going to take 6 months to change the application. And with this, you could just sort of swap in the proxy and tweak the SQL on the fly, and you should still probably change the application. Maybe this is just a temporary way to do things, but this is something that can be put in place almost instantly.
What about testing?
You don't need
What
that.
about it?
So production's for.
Well, so does Gallium itself provide any additional I mean, it's got a debugger, obviously, but does it provide any additional like unit testing, or obviously, I guess, integration testing tools, or maybe some mocks and stubs that can allow you to write unit tests?
There are products for that, and it is programmable, and you get the full JavaScript engine. Plus, all the JavaScript code has full access to the underlying Java, so you get to the full power of JavaScript plus the full power of Java. That's a lot of power, and therefore there's very little that you can't do in theory. But what is it that's that makes sense? There are a fair number of products out there that will do things like mocking databases, generating random data for testing purposes. So I would say maybe sort of look at that because they're specialized products. That's what they do. Could you do the same thing in Gallium data? Well, theoretically, probably yes, but is it the best way? That's a more difficult question.
Yeah. Well, so again, thinking about my current environment, right? QA is going to show up and say, how do I test that? The devs are going to say, you've told us you want us to do things like TDD. How do we do that here? And then my best friend, the CISO, is going to come and talk to me about all of the security implications of a thing like this. And that's why I was poking at the SSL thing. It's like, I don't know. Do you remember Data Joiner? IBM Data Joiner from back in the day?
No, I don't.
There were all kinds of concerns about the securability of your connection through Data Joiner. That was 20 something years ago when we were at Versata, but
yeah, one possible use of this is, by the way, in the realm of security. So there's a number of these. First of all, you can have a granularity of let's say connection security that you can't really have with other products. Every time a connection comes in, you can execute a script, and that script can basically do whatever it wants, based on the IP, based on the time of day, based on whatever parameters, the phase of the moon. It can decide whether or not to accept that. Another interesting application that sort of almost fell out, off the turnip truck by accident was a few months ago. We realized, we could actually record the queries from a database client into a database, like a Redis database or whatever, and just sort of basically sort of create a profile of what this application is doing. And then once we've sort of run the application for a while, we're going to get to the point where we can decide, at this point, we have seen all the requests that we're ever going to see, all the types of requests, right? Applications don't usually use an infinite number of request types. So after a while, you're going to realize, we're just repeating ourselves now. All the queries are the same. And therefore, this is a great time to lock it down. And lock it down means that Gallium data is now going to say, if I receive a request from this application and I've never seen it before, I'm going to reject it because that's unexpected. I've been running for the past 3 months. I've been recording every type of request I've ever seen. And any new type of request from this application is now going to be considered to be surprising and therefore not good. So there's a lot of stuff that you can do here, and we keep running into new types of applications.
Yeah, that's a cool idea.
That's a super cool idea.
And it's actually one of our tutorials. It takes about 5 minutes to put in place. We use Redis as a database to sort of cache the requests, but it's super simple. The entire thing is done, if I remember correctly, with about 12 lines of code in Gallium data.
The ability to look at a data set that's over 40 years old and know what parts used, so you can delete the rest, would be amazing. Like,
yeah.
Although I think there are probably tools that are more sort of specialized for that, and that will sort of build heat maps of your data. But this is a very generalized tool. This is not a pinpoint solution. This is something that can be used to create a lot of different types of solutions.
This is person in the middle, like
with
a programmable interface.
Exactly.
I mean, you could almost get rid of your database and switch to something different if you just could intercept all the calls.
Yeah, I mean, if you'd have to go pretty crazy there, but in fact, you can do things like and we've seen this where a request comes in and Gallium Data is going to say, oh, you know what? I'm just going to respond directly. I'm not even going to send it to the database. I know exactly what you mean, and I'm going to sort of send you the response immediately. That can be done with caching or by generating data or by retrieving data from something else. So an example that we have, for instance, is translating prices using the current exchange rates, right? Mm-hmm. So I get a result set, it's expressed in Canadian dollars. Can you please translate that to US dollars for me using, the current currency rates from the past 5 minutes? Again, that means the database doesn't change, the client doesn't change, and yet I've just changed how prices are expressed in my application.
So it's a complete interoperability programmable interface.
Well, yeah, I mean, again, you sort of have to be wise about it. It's a lot of power, and you don't want to sort of.
Well, you don't want to build a duct tape mess.
Exactly.
But in some legacy apps, it's your only option.
Exactly. So, the pushback that we get very often is, but that's not the way it should be, right? We should do it right. We should change the application. We should change the database. And my answer is absolutely. If you can do that, please do. That's the quote unquote right way to do it. But this is the alternative, and very often it's a lifesaver.
Yeah, I mean, I think there's so often market pressure. Right, we need this feature, we need the security compliance. GDRP changed, and we have to do this thing right now, right? And following our normal SDLC, whatever that happens to be, could take us weeks or months, and we need to respond. My favorite background story on that one is if we don't fix it by Friday, the vice president's going to jail because we're violating GDRP, right? And it's like, and the plan is a 6-week plan, but if we had a tool like this, we could fix this in 2 hours. It's just data in that particular case, it was just data masking, right? Too high of a resolution on GPS recordings without an opt-in. They changed the law on us and then came and said, we're taking somebody to jail on Friday if you don't fix it. And we're like, holy crap, we only have 5 days to fix this. Are you kidding me?
And then
Well,
Rich called
Bob.
a recruiter.
Oh, we solved the problem with one very nasty Java or SQL statement. We just went and trimmed the precision of GPS coordinates down to you were in Germany somewhere, as opposed to you were standing on that street corner. So anyway, yeah, no, this is really cool. Like I can imagine a lot of not just bail me out of trouble problems, but some real genuine governance tricks and master data tricks and wiring this into event-based systems. Hey, this doing analytics, dead code elimination for legacy systems, all kinds of cool stuff.
Yeah, much to my surprise, the one of the strongest responses we got from some of the articles we published was on data masking. Data masking, I didn't even know that was a thing, but there's a whole industry out there of people offering to help you mask your data. I don't want to see the full social security number, right? Just the first 3 numbers or just the last 4 digits of credit cards. And I need to do that sort of system-wide. I've got applications in COBOL and C and Lisp and God knows what else, and I can't possibly change those. They work. I can't get rid of them, but changing them is just a daunting prospect.
Cool. Any other questions from the group? Hey Val, welcome back. Max, I appreciate everything you presented today. Someday, maybe you'll want to present about how you sold your thing to Broadcom. I think that's a lot of people's dreams, right? And then, we'd love to have you guys come back. I mean, Val, last time, amazing. Max, we'd love to have you come back, talk anything you really want. Super nerdy. The more hex, the better. Rich, like,
careful what you wish for there.
Sorry, go ahead, Max.
No, okay, careful what you wish for. This can get truly nerdy when you get down to the wire protocol level. That gets mind-numbing.
Well, this group would be happy to talk about the difference between big endian and little endian, right? And bit flipping and ECC RAM. Like this is, and also we can talk about how to be a CTO of a publicly traded company too. But we're code. Anything kind of goes in code as long as it's code. So amazingly interesting conversation. Timothy Wright says thank you, and I'm gonna go ahead and shut off the recording and